One thing that is a bit difficult and annoying when you're building an astrophotography rig or you're adding equipment to your existing rig is that you need to take into account all of the interdependencies and inter-requirements that some pieces of equipment have towards another. For instance, if you're using a telescope with a focal reducer with a 55 millimeters of back focus, you need to make sure that all of your accessories between the camera sensor and that focal reducer will be exactly 55 millimeters and not more, because then we're in trouble. Or you could have like, okay, will this off-axis guider be compatible with this camera, even though this camera is full frame, and all this kind of stuff that makes things a bit difficult when it comes to really building your stuff. And so I very often receive messages from people about like, well, this work with that, or is this a good telescope knowing that I'm using this camera, or this and that and this and that and this and that. And I'm like, obviously I cannot answer everyone, unfortunately. That was like roughly a year ago, a bit more than a year ago. I was like, there must be something better. And there's a website on the internet called PC Parts Picker that lets people who want to build their own PC figure out which parts will work for their PC and whether those parts are compatible with one another. And I thought, I'd love to basically have a website exactly the same thing, except that it's Telescope Parts Picker, where you can choose your control center, your camera, your reducer, your telescope, your focuser, your filter wheel, your filters, etc., and be reasonably sure that everything is going to work well together. And so a year ago, I actually started writing specs for myself and drawing some mock-ups and stuff like that. And I kind of abandoned because, I don't have the development skills required to build something like that, and I was too lazy to figure it out. Until recently, I decided like, hey, people are vibe coding all over the place, so I vibe coded my solution. And I want to show you how this looks like and how you could test out what I have, as well as I want to tell you about all of the limitations that my prototype has for now. So with that, let's get into the meat of things. This is what we get. So this is Telescope Parts Picker. Build your perfect astrophotography rig. And I'll show you how it works really. I decided to really split it into two, like one for smart telescopes, because smart telescopes actually let me build something first and see whether it worked and whether it was feasible, and then build your own rig, because that's where the real complexity comes in. But let me quickly show you smart telescopes in the first place. Basically, you get a very standard kind of interface, and if you select a smart telescope, you'll see their field of view on a variety of targets. My targets, by the way, they're configurable. I can basically set an image URL, tell the software what the pixel scale of that image URL is, and then it will overlay this rectangle onto the image, so we can see what it's going to look like on various targets across all of those smart telescopes, which I think is overall pretty cool. We can go through them, and with each of the smart telescopes we can look at all of the details, all of the specs, like the pros and cons type of deal. I think it's pretty cool. And then when you're ready you want to purchase something, like you can simply go towards the purchase button there, and it gets you to Agena Astro. For the moment, I've used only stuff on Agena Astro, and I have, because why not, use my affiliate links, after all. I want to add stuff for SVBony, for TopeTech in the future as well, because they're not available on Agena, right? So this does mean that for now it's really meant for the US market, but again, it's a prototype. It's not really meant for real world use yet, unless you want to test it, in which case let me know how it went down in the comment. Of course, I'll have the URL down in the video description and down in the pinned comment. Anyway, the meat of things, where it really gets interesting, is under build your own rig, because that's where all of the interdependencies come into play across all sorts of equipment. And for now, I have limited myself to the most popular equipment. It's still a lot of stuff that I had to manually input, manually check the specs, manually amend the stuff that the AI had invented, and manually set up the interdependencies to say like, no, this is not going to be compatible with that because it's a coma corrector that's specifically for the Quattro series of telescopes, that kind of stuff, right? Or things about, this filter is for color cameras, not for monochrome cameras. All sorts of stuff all over the place, but let me show you really how it all works. So first, you need to select your control center type. Basically, you have the choice between a standalone PC and ASIair. I want to add like a Stella Vita, something like that in the end. Or you can choose a smart camera. And each of those gives you a different path with different equipment options available. Obviously, for the ASIair, the equipment then gets filtered for when it comes to camera, guide camera, focuser, filter wheel, that kind of stuff, or rotator, ZW stuff only. If you select smart camera, same restrictions, but you're also restricted to smart cameras, obviously. So let me show you standalone PC though. That's where you can support everything. And I have like as a placeholder the Melee Quieter 4C there. And you can see that immediately we have the price added and the total weight of our imaging train that starts to get computed. And then because I've chosen a mini PC, something that doesn't happen if you chose the ASIair or the smart camera is, hey, you may want to get power delivery stuff like a power cable for your Melee PC, and then power delivery for the rest of the equipment. And immediately the weight and also the cost goes up. Ooh, yikes. And then you go to the next step, which is we're now on step 2, the camera. And here I have like various popular cameras that are available to us. But let's say you can select filter by color or monochrome camera, price low to high, etc. But let's say I feel rich today, so I'm gonna buy a full frame camera, and this is a full frame monochrome camera, and you can see immediately the weight and the price goes up. We have all of the details. We can get more information within this little card here. I have a link to the specifications that's not even an affiliate link. I need to fix that. But here we go. We have the camera selected. Let's go to the next step, which is going to be my telescope selection. And then when I'm on my telescope selection, what the program does is that based on the camera specifications, it computes the sensor diagonal, and then it compares the sensor diagonal to the image circle supported by the telescope. And it only shows you telescopes that have a sufficient image circle. And here are those, or that can have a sufficient image circle once you add the flattener, the reducer, that kind of stuff. You can tell that immediately already it starts to get complex. But for me, for now, it's only refracting telescopes. I can show incompatible equipment, and suddenly we have stuff like the RASA 8, we have stuff like a Mach-Newt telescope, and we have some Newtonians as well in here. But they're not compatible because full frame is not really meant for those telescopes. I'm on my streak where I want to spend a lot of money, but the SQA 106, if I select the SQA 106 and I go to the next step, I don't have any reducer flattener to choose because there's none that you need or you can use for the 106, so it's not fun. So I'm going to go back and instead I'm going to select, let's say, the ASIair 120 because I want a long focal length. And you can see that the moment I select a telescope, I have my field of view there, I have my pixel scale, etc. I have all of the good stuff available to me. I can also rotate that field of view to see like what it looks like if I can reframe, and I can, yeah, indeed, almost frame the entirety of the Andromeda Galaxy. With the raw telescope, I can check what it looks like on the Pleiades, on the Horsehead Nebula, and maybe like on the Crab Nebula. This one takes a longer time to load because it's images from Wikipedia, and they're very heavy when it comes to those targets. I think it uses like NASA images. Maybe I can try something else. The Pinwheel Galaxy might be faster. We'll see. There we go. Pinwheel Galaxy is still pretty small in the field of view, but that's because we're using a full frame sensor, right? And something that has appeared is that we have the available optical backfocus for this particular telescope. If I select the SQA 106, we have a backfocus range that's available to us because it's a Petzval design. So same for this guy here. So you can see it's pretty advanced there in terms of figuring out what's going on. And then we have used backfocus 17.5 millimeters because your camera uses the 17.5 millimeters of backfocus. And of course, our price is super high, but whatever, I'm feeling rich today. And now, because I've selected a telescope that supports flatteners and reducers, I have a list of flatteners and reducers that are compatible with that specific telescope, none of the others. If I show the incompatible equipment, you can see there's other reducers, flatteners, coma correctors, etc. that are available here, but only the ones relevant to the telescope appear. Let's say that I want to show you also the impact. If I click on this, suddenly we're zooming out a bit more. It's probably a bit more visible on the Andromeda. Zoomed in, zoomed out. So it takes into account, of course, your flattener there, and it tells you your updated field of view, updated pixel scale, etc. Pretty cool stuff, if I say so myself. Same for the effective focal length and focal ratio that gets updated, right? I think that's super cool. Anyway, we have that kind of stuff, and now I'm able to go to the next step, which is the focuser. Currently, I only have two in there. They're EFs, they're basically compatible with every single telescope out there. Although, like if you had selected the RASA, it would still have given you the EF, and I don't have like the specific adapter. So it's not perfect. You might have to buy additional stuff than what the website says, but it's still, we're getting pretty close. Let's say I'm still expensive. Normally I would only go with the EFN, but I'll go with the EF Pro because I'm feeling rich. And again, you can see my weight here keeps increasing. Okay, and so now we can get to the next step, which is choosing a filter wheel or filter drawer. And here we have a monochrome camera, which means that really a wheel is more necessary. But you can see it still gives us the option between the two. I can show you the incompatible filter wheels and drawers as well. There's a few of them, but it rejected a lot of them based on several things, based on things like the filter drawer thread size being M48 compared to M54 for the camera. So really for the full frame camera, you need this guy here and not that guy. And also, it did something pretty cool, which is here, minimum filter size for your equipment. It uses your focal ratio together with your sensor diagonal to figure out what is the minimum filter size for your equipment so that you don't get too much vignetting on your equipment. It does assume a distance from your camera sensor to filter of around 25 millimeters, but it does that computation and makes sure that you're only able to select pieces of equipment that will support a size of filter that is above this or equal. So yeah, we're getting some pretty cool results there. So let's say I want obviously the filter wheel because it's a monochrome camera. Immediately the backfocus gets updated. We're really getting closer to having completed our rig, and now I can go to my filters. And again, the filters are limited to stuff that are compatible with your camera, which is like this 2-inch ZWO filter set, or this super expensive 3 nanometers SHO plus LRGB filters from Antlia. The filters are filtered so that only the ones that are compatible with your filter wheel or drawer appear, which is M48 in our case, but also these guys here, for instance, they're 2-inch filters, but they don't appear because they're for color cameras, because they're dual narrowband. So I choose not to show them because we selected a monochrome camera. All of those rules are all over the place. It's a nightmare, seriously. But let's say I feel very rich today, so I select those filters. Fun thing, when you select filter, it removes 1 millimeter from your used backfocus. Not sure if that's right to do, but technically it is, right? So I can go to the next step, and now we can select what we want to do for guiding. And I could say I want to have an off-axis guider. Probably, yeah, an off-axis guider is better for this type of focal length, right? 672 millimeters. I'll do that, but I'll just show you what happens if I select like a guide scope, and then I select a guide camera. So you have the choice of multiple guide cameras. Because I'm using a PC, QHY cameras are also available. But let's say I choose the 174 here, you'll get a warning because it will compare the pixel scale of your guide setup to the pixel scale of your main imaging camera. And if it's above 5 times in terms of ratio between the two, it will warn you that maybe it's not enough to have proper guiding. And it also tells you here, right? So it really gets a bit, I guess, too smart for its own good. But let's say, okay, I want the OAG instead, right? So with that, it has remembered the camera and it tells me the guide scope pixel scale is 1.6. So we're fine. So it ensures good guiding. I can choose a different sensor, and now we're almost at the same thing. And here we go. We're getting really some cool results, and you can see that the used backfocus is really what we need. Yeah, I know it's not quite the same figure, but you can get the idea that we are in the vicinity of what we need. So now we're done with guiding. We can choose a rotator if we want to, but if I select it, you can see that now our used backfocus is above the available optical backfocus. So we cannot choose it. We have to stay below $10,000 for now, and we haven't even chosen the mount. So we're going to skip the rotator, and now we can go to the choice of mount. And here I don't filter out any mounts based on weight because I really want to have the user to have some agency here. But you can see the total imaging train weight is around 10 kilograms. If you look at the AM3, it tells us that it's 13 kilograms with counterweight, 8 kilogram without. If I select it, you can see it will tell you the max mount payload with counterweights in this case, which, you know, I think it's not quite good enough. So I would go with the AM5. Maybe I could select like the 150i, works well as well, or something like the WD-20, right, to have a lot of room to grow there. But let's say I want to go with the ZWM5 and tripod, and now I click next, and there we go. Our rig is built. We have everything we need. We have the whole summary there, and for each of those items, you can click the link, and it will redirect you to the piece of equipment. At this stage, only on Agena Astro, right? But I think, honestly, this is pretty cool, and despite the fact that this was coded by AI in the end, again, I cannot tell you how much time I spent on this. I think my specifications document is like 40 pages long. Some crazy stuff. But yeah, that's an example. I want to quickly show you what it would look like if we select like a smart camera, for instance. If you select a smart camera, suddenly you only have the choice between smart cameras. You can choose the one that you want. We could go with the 585 ASIair, for instance, because now we're cheapos. We want to go for a cheap rig, right? So the 585, now I have more telescopes that are available to me. I'm going to sort them from low to high. And yeah, maybe I'll spring for the SQF55. I really like this telescope, so I might spring for the this guy maybe. Okay, you know what? Let's go for this guy. But it's f6.9. Does it have a? Yes, it has a reducer, but it increases the price to above the SQF55. And what about this guy? It's flat field, so it doesn't need a reducer, but it's f6.8. Okay. I'll go with the SQF55. I could go with the Newtonian as well, in which case I would need to choose the coma corrector, but $0 because it's included. So let's simply choose. I need to unselect that. Let's choose the SQF55, and we can keep going. So no flattener, and then it's all the same thing, right? You select the stuff that you want. You have different filter wheels available and drawers available this time because it's a color camera. I'll go with a filter drawer, and again, this time we have different filters. Let's say I just want an L Extreme, and maybe also I can choose two filters, L Extreme and L Synergy. Okay, we're getting a bit expensive, and here it doesn't ask me really for an off-axis guider, even though there are off-axis guiders compatible with that kind of camera, simply because there's one integrated within the camera. So I can skip the guiding and the camera stuff. I'll add a rotator. And now we're at the proper back focus in between those two numbers here. So we're good. Choose the mount. This time the weight is much lower, so I can go with maybe the 100i because it's fairly cheap. And next, and there we go. We have our rig assembled. I can start from scratch again, show you what it looks like with the ASIair. I can select Mini or Plus, right? Mini because I'm cheap. And then I have all of the ZW cameras compatible with the ASIair Mini. I could choose like an MC Duo camera. And again, we're in the stuff. We just select our stuff that we need and look at the field of view and all of that kind of stuff. Another little detail that I put in is that if you go for a QHY Minicam 8 camera, so let me select the stuff for the PC so I can have the Minicam 8 appear. Let's say you select the one with the 3 nanometers filters, click next. Then you select your telescope. Let's say I'm going to take the one that I have, the Quattro 150p. Said I want the coma corrector and it's included in the price, so it's $0. Focuser, and then again you have the filter wheel. It just tells you like, yeah, you're also getting this filter wheel for there is $0, and it doesn't show anything else, right? That way you're not confused and you select exactly, you know, what you basically selected, right? So same for the filters, and there's $0. And now you can go to guiding, and again for guiding I'm being pretty smart in that I show only a guide scope or the QHY off-axis guider specifically for the Minicam 8, which I can select, and that puts me exactly at those 55 millimeters of back focus. I can select a camera, but I'm going to take one from QHY, right? This one, for instance, and click next. I don't have the space for a CAA, so I'm going to skip that, and then I can choose my mount, let's say this guy, and we're good. So here you can see it's a lot of cool stuff. I think I'm pretty pleased with what I've been able to accomplish there. Yeah, let me know what you think of that down in the comments. Leave a like while you're at it. I'll have the link in the pinned comment and in the description if you want to try it out. And might try to put a QR code to that link as well. It's a pure prototype. It's not working properly. There's a lot of stuff that is not perfect, but I thought it's super cool, and I wish we could have some stores like Agena Astro have this kind of tool within their website, so we could have that. But then I'll show you in a moment the actual data management side of things. You'll see it gets a bit crazy, and so I understand why Agena is not really able to maintain something like that. But then, you know, alone I was able to put this kind of equipment in there. So yeah, maybe I should keep going. Let me know if I should keep going, add equipment. Maybe I should make available upload files for you guys to put in equipment you want to add to this website, and then I can just upload them into the website. And that's a good segue to the actual admin interface for this website. So just to show you, we have an admin interface where I have all of the equipment that I have imported in there. So typically I ask the AI to import the equipment, and then I had to manually check and amend the specifications and check and amend, not check, actually just add the interdependencies and compatibility restrictions for each. It's some crazy work, and there's tons of ways that I've accomplished that, and I've spec'd out saying like, yeah, I want to be able to do it specifically this way. I can also export all of those items and import back new ones as a TSV file. Again, let me know if you want the format of this TSV file and you want to add your own equipment. And then I also have my targets definition for the field of view stuff, where I have the link to a target, the pixel scale of that image, because I had to then solve the image in PixInsight each time to get the proper pixel scale. That way we can display the field of view on that. So some crazy stuff. And in there we can look at a lot of things. Let's look at a control center, the ASIair. Where is it? So I'm going to just filter by control center. Let's say the ASIair Plus. And let me show you what it looks like in there, because I have, you know, a standard list of specs, but I also have restrictions here. For the focuser, only show brand ZW. For the rotator, same thing. For the guide cam, same thing. For the camera, same thing. For the filter wheel, same thing. And it can get, oops, I want to go back to the admin interface. And we get the same type of stuff if I go to like a smart camera, where I have the camera type as smart, which is used by the software to make sure that it only displays those smart cameras when you choose that category of control centers. And we have a very similar thing. And we have other stuff like let's look at the QHY Minicam 8. What kind of restrictions do we have? So first you can see that it has all of the information needed by the software to figure out the diagonal, so you can figure out which filter sizes are correct for that, as well as the back focus consumption, and the sensor type, which is used by filters to figure out whether it should be displayed for this camera. And then in the restrictions, we have some interesting stuff in that I have some whitelisting, like for the filter, only display this particular filter. For the off-axis guider, only display this particular off-axis guider. For the filter wheel, only display this particular filter wheel. So we do have some interesting restrictions on top of that. And if I show you some filters as well, there we go. The filters, if I open one of them, you can see that in the specs, we have the size, of course, which is used to determine the suitability of the filter to the filter wheel / filter drawer. But we also have a restriction here with the camera being limited to a color sensor type. That's how it all works together. So there's tons of different ways that those restrictions happen. And if I were to export all of that to a TSV file, you'd be able to look at all of the JSONs that I've defined for specs and restrictions and how it all works together. It's honestly a lot of work to maintain all of that stuff, but that's how it works in the back end, right? If I open up like another telescope, let's say this guy here, let's see what information I have on there. I have the minimum backfocus, maximum backfocus. That's super important. We have the focal length, focal ratio, and aperture. That's super important for the display of the pixel scale and the field of view, but I don't have further restrictions. Other telescopes have different restrictions available. It really depends on the telescope. And of course, if you look at a chroma corrector or a field flattener, focal reducer, we have in there the reducer factor, which is used to figure out the new focal length and therefore the new field of view that you have on your little preview icon on a variety of targets. I think it's all. I mean, I feel like I'm patting myself on the back, right? But I think this is pretty fun. I think this includes a lot of stuff, and I kind of like what I've accomplished, but I don't know if it's really practical. For now, we just have a prototype. I'm sure the code behind it is a complete nightmare. But again, I'll have the URL in the description, in the pinned comment, and let me know how it works out for you, whether you'd want for me to kind of open up things so you could import, or at least send me equipment lists to import with the restrictions and with the specs. And I could also publish, a list of restrictions that are possible with the various JSON formats that we have in there. Let me know down in the comments. Leave a like on the video if you like that. I think it's been a fun experiment. I've had a lot of fun doing that. But again, I'd love to hear your thoughts. If you want to support me even more and you're planning on buying anything from Agena, High Point Scientific, First Light Optics, or even Amazon, even if it's unrelated to astrophotography, if you do so after clicking one of the links that I have down below in the description or the pinned comment, it will help me out at no cost to you. And if you want to help sponsor the channel and sponsor this kind of slightly crazy initiative, you can join the channel as a member. It's the join button next to the subscribe button, or join my Patreon, and that's the link is down in the description. You guys make all of this possible, including this kind of crazy experiment that we have here. And again, I'd love to hear your thoughts. And I might actually reach out to shops like Agena to ask them, like, are they interested in sending me like equipment lists to upload in there with the restrictions? And if they are, we could expand this catalog that I have here. But we'll see. First, I want to know if you think this could make sense. I'd love to hear your thoughts. Thank you so much for watching. Don't forget, whenever you can, to look up at the stars, and I'll see you next time.